All right, everyone, we are going to be discussing graphing absolute value functions. Okay, we're going to be starting that on page 27, so you can go ahead and turn there now in your 6B packet. All right, so just first off, this is done completely differently, or completely different than when we were solving absolute value equations. Okay, let's go ahead and just take a look at them, visibly first. So absolute value equations, all right, they only had one variable, in this case x, in the equation. All right, whereas here, you'll notice we have a y and an x. We have two different variables, okay? So just like with linear equations, when we graphed things, or when we had two different variables, we graphed the ordered pairs that came out. And then when there's just one variable in an equation, we can actually solve for that variable and get numbers, all right? So again, it is not going to be like that. We are going to be doing something a little bit different. So let's go ahead on page 27 and go through these first couple together. So what you'll see is something that looks like this. Okay, it's y is equal to, and then you have the x inside of the absolute value bars. Okay, so what we're going to be doing is we're going to be plugging in x values, and you'll see that there's already a table listed on each of these with x values that you're going to plug in. In the future, we're not going to have that, so we're going to have to learn a way to deal with that. But for right now, they give you some values. We want to get some negatives, some positives, and 0 in there. So let's go ahead and plug these in. All right, let's go ahead and plug these in. So if we were to plug in -2 into x, we have y is equal to the absolute value of -2, and therefore y equals 2. Okay, so we can plug that in. If we were to do the same thing for -1, I'm not going to plug every single one in here. If we put in -1, that would turn positive because the absolute value of -1 is 1. Plug in 0, absolute value of 0 is 0. Absolute value of 1, is also going to be 1. Okay, we had gotten that answer already. Interesting. If we plug in 2, well, the absolute value of 2, we'll do another one like we did -2. Well, the absolute value of that is also going to be 2. Okay, so you'll start to see that some of these repeat, and they're supposed to do that. So let's see. Let's go ahead and graph this and see what we get. I'm going to go ahead and make this middle point red. That'll become more clear as to why I'm doing that in the future. There it is. And let's go ahead and graph the other ones. We'll do that in black. So we have 1, 1. We have 2, 2. And then we have -1, 1. And -2, 2. There you go. So we're going to go ahead and connect these, and technically, although it gave you these values, we also could have plugged in 3, 4, 5, 6, and so on and so forth in the other direction as well. So this is going to be an arrow when we draw them. So let's go ahead and choose that one. There we go. And same thing going in the other direction. So you'll see the shape that gets drawn or graphed when we graph an absolute value function is a V, okay? V for value, value, all right? So yeah, there you go. So we're gonna get a V shape. Now, this kind of makes sense as the values that you plug in for x, whether they're up here in positive, you're gonna result in a positive y value because the absolute value happens even if you plug in a negative x value. When you take the absolute value of that, you're gonna get a positive y value. So it kind of makes sense that we get this V shape. Let's go ahead and do another one. So this one right here, let's plug in -2 again. And again, we're not going to write in every single one right now in this demonstration, but that might be a good thing to do. So y equals, so the absolute value of -2 is just 2, and 2 minus 5 is -3. So we get an answer here, let me write it a little bit smaller, is -3. If we were to plug in, -1, we would get, the absolute value of that is 1. 1 minus 5 is -4. All right, let's go ahead and do a couple more now in our heads. So if we plug in 0 here, absolute value 0 minus 5 is -5. If we plug in 1, 1 minus 5 is -4. And we'll start to see this pattern again. -3 is what we expect to get. So we plug in 2, absolute value is 2, minus 5 is 3 once again. All right, oops, sorry, -3. So we could go ahead and graph this again. So we have -2, -3 down here. We have -1, -4, 0, -5. I'm going to go ahead and graph that, like I said, in red. 1, -4, and 2, -3. Now, the reason that I graphed that middle point with a red, red point is because this is called our vertex. The point in which our two lines intersect, okay, and meet is called the vertex. And that's going to be very important, especially as we talk about our other method for graphing these, which we'll do in a short bit. So this is what our graph will end up looking like. Notice that we had this -5 here on the outside, and look where our vertex moved down to, right? It moved down 5. So this will start relating back to transformations, like we talked about when we talked about graphing linear equations. So what I want you to do is we're going to skip 3 for right now, just because I'm not going to do every single problem on the video. I want you guys to go ahead and try number 4 with the points that they gave you for x. I want you to try plugging them in, okay, and then go ahead and graph it and see what it looks like. So you can pause the video, and now you're back. All right, we're going to go ahead and check the answers. Here it is. There you go. So you'll notice that our vertex kind of shifted to the right. And notice we plugged in some different points here for x, right? We plugged in different points. We're going to need a little bit of guidance in a little bit of where to, which points to use, because, it's going to be difficult to find this vertex if we don't know which points to use. Especially say we just plugged in -2, -1, 0, 1, 2. Well, if we plug those in, we wouldn't have even gotten to the vertex, right? The vertex is at 5, 0. We would have graphed something like here that just looked like a straight line. So it is very important that our vertex is involved in our graph, and we're going to learn how to do that in a short bit. All right, here we go. Let's go ahead and do one more. Now we have this number out here, this 2. So let's go ahead and try these out with the x values that it gave us. This is number 6. So I'm going to write this whole thing out. And let's plug in an x. We'll do -7 first. All right, so y is equal to 2 times the absolute value of, this becomes -2. All right, now from here, a lot of students see this negative inside here and they say, oh no, negatives are not allowed in absolute value. But in fact, that's not how it works, okay? What happens is we are going to calculate inside the absolute value until there's only one number left. And then we're going to take the absolute value of that. So for instance, right now, we have y is equal to 2 times 2, because the absolute value of -2 is 2. So this becomes 4. All right, I'll go ahead and write that with a smaller mark. All right, so again, this absolute value, when you have a number squished up against it like this, that does mean multiplication. But first you want to go ahead and calculate it. It takes the absolute value of it, in this case 2, and then you can multiply. So let's go ahead and do a couple more. If we did -6, I'll do one more written out. -6 plus 5, and that's going to be times 2. Well, this is going to equal -1. And the absolute value of -1 is just 1. So we have 2 times 1, and therefore y is equal to 2. All right, here you go. Let's do a couple more in our heads now. So -5 in here plus 5, that's going to be 0. The absolute value of 0 is obviously 0, and 0 times 2 is 0. -4, -4 plus 5 is 1, absolute value is 1, times 2 is 2. And then -3 plugged in here, -3 plus 5 is 2, absolute value of 2 is still 2, times 2 is 4. Okay, and you'll notice this starting to reflect here because our vertex is here in the middle. All right, so let's graph that vertex first. -1, 2, 3, 4, 5. Oh, I might have miscounted. 1, 2, 3, 4, 5. 0. And we'll go ahead and graph -6, 2. -4, 2. And -3, 4. And -7, 4. All right, and we'll go ahead and connect them. You'll notice this one's looking a little bit different than our previous ones. Yes, obviously our vertex moved a little bit, but it's also looking a little bit more of a steep V, right? Look at how this is a little, it's kind of like stretched up here, towards the top. This is going to be called a vertical stretch. We're going to talk about transformations at a different time, but yeah, because of that 2, okay, right here, that is going to cause it to stretch up. So here's the thing. You might be thinking, there's got to be an easier way to do this. Do I have to make a table and plug in every single one of these values? And the answer is no. There is a better method, or at least a quicker method. And what that's going to be is going to be called Vertex Form. All right, here it is right here. We're going to talk about it more right here. All right, so at the top of page 28, you can head there now. So Vertex Form is as follows. Y is equal to A times the absolute value of x minus h plus k. Okay, and the vertex can be found with h comma k. All right, h comma k. Let's go ahead and highlight that. Yeah, sounds good. All right, cool. So h comma k is what we're going to be looking for. So here's the big thing to note. You might be wondering why I highlighted this negative value in front of the h. That's what's going to cause most students trouble in finding our vertex. Let's go ahead and find our first one here. So if we look at this first one, okay, I'm going to go ahead and draw parentheses here for my for my ordered pair, but that is the vertex. Now there is nothing being added or subtracted inside the absolute value with the x. So it's kind of like we have a plus or minus 0. So I'm just going to write 0. Okay, there is no horizontal modifier here or translation. And then there's also nothing being added, right? It's like kind of a plus 0. So it's kind of like k is 0. So our vertex, when there's nothing on the inside and outside being added or subtracted, is just 0, 0. So here's our vertex for the first one. Let's try this one out. Now it says that h is our x value. Well, right here, this is plus 3. Oh, I looked at the wrong spot. Let's start down here for number 2 first. All right, so when we're looking inside here for h, well, it says minus 4. So minus 4 was h, so therefore h must be 4. And then there's nothing on the outside, so therefore k is 0. So our vertex is 4, 0 here. All right, now we come up to this one. Well, 3 is there for h. Well, it's a positive 3. In order for that to have switched from a negative to a positive, there must have been a negative 3 plugged in. All right, and then there's still nothing out here for your k value. So that's just 0. Now let's go ahead and do this one. We have something in both slots now. So once again, in order for this to have switched from a minus in the equation or the formula to a positive, it must have been a negative number, so negative 1, and this is plus, so therefore this must be a negative 2 as shown. So one thing I like to think about is that the x value of your vertex is going to switch from what your equation looks like, and your y value is going to stay the same. Okay, x is the liar, y is telling the truth. So we're going to go ahead and apply that now right here. So like I said, I told you there's an easier method, and that's what we're going to go ahead and do right now. I'm still going to make a table, but it is going to be much, actually no, I'm not going to make a table. I take that back. We're not going to make a table using the shortcut. So this one you're just going to watch. You're going to have plenty of time to practice these on pages like 30C and 31, which we'll be doing for homework. So let's go ahead and try this out. So you're always going to have to start by finding the vertex. No matter what, using the shortcut or making a table, you're going to have to find the vertex. So right here, I see, let's grab vertex form again. Here we go. We'll make the whole thing black. There we go. So vertex form, if we remember, we're looking for the opposite of h. Okay, so therefore this would be a positive 2. And then the positive 1 just comes right down because it is positive in the formula. So there's our vertex. We're going to graph that right off the bat. 1, 2, 1. There you go. And now your a value, okay, this value right, there you go, right here, okay, is kind of like what I call your fake slope, okay? It is going to be your rise over your run. So let's go ahead and write it as a fraction, all right? So that is like 4 over 1. Now from your point, okay, you're going to have to go ahead and decide, or you're going to have to go ahead and do a rise over run. Now, the other step that we want to look at is because this is a positive value, okay, your a value is positive, you're going to have an open upward v, all right, a v that's opening upward like, like an actual v. When they open downward, okay, that's going to be a negative a value. So this one has a positive a value, so therefore we are looking up. And here we go. We're going to go ahead and count up 4 and over 1. So here we go. We're going to rise 1, 2, 3, 4 over 1. Now here's the thing. We know that this is a vertex, so it's going to make a V, and this is the middle of it. So we're also going to count up 1, 2, 3, 4, and run 1 to the left as well. And that's why I call this your fake slope. Okay, we're not treating it like a true slope, but it does get you the idea. So you go up 4 and over in both directions 1, and we can keep doing that. We could do another up 4 and over 1. And another up 4 and over 1. So here we go. Let's go ahead and connect these, make our V. And there you go. All right, so we're done. That's it. We didn't have to make a table or anything. So just to recap, we found our vertex. In this case, it was 2, 1. And then we used our fake slope to count a rise over run. And we went up 4 over 1 in both directions, up 4 and over 1 in both directions. All right, let's go ahead and try 2 more, and then we'll be done. This is on page 30B. All right, so we're going to show you how quick this really can be. All right, feel free if you want to just try that yourself, you can pause it. All right, and then we're going to go through them together. All right, here we go. So we're going to start with the vertex. Our vertex here is going to be -1. This switches to this being a -2. This stays the same. I'm even actually find the vertex on this one already. This one is 3, and this one stays as -1. So where we have our 2 vertexes, let's go ahead and graph. 1 to the left and down 2. And then we're going to use our slope. Okay, this one's not slope, fake slope. This is our A value. All right, so we're going to go ahead and rise and run with 3/4. Now this is positive, so therefore this is going to be upward facing like a V. So here we go, we're going to go up 1, 2, 3 over 1, 2, 3, 4. Now I'm going to reflect that and do the same thing in the other direction. So up 1, 2, 3 over 1, 2, 3, 4 this way. And you know what, I'm going to add another point. 1, 2, 3, 1, 2, 3, 4. Same thing this way. 1, 2, 3, 1, 2, 3, 4. There you go. Notice this one's shallowed out quite a bit. And you might be thinking about a vertical shrink. Okay, think about our transformations. Well, we have a 3/4 A value, and that kind of shallows out our the slope or the steepness of our line. All right, let's go ahead and do one more. This one, we're going to start by graphing our vertex. 1, 2, 3, down 1. Oops. Yeah, we'll go with this. 3 and down 1, there you go. And then we are going to decide, does this open up or down? And because it is a negative, it's going to open down. All right, so we're going to go ahead and go down 2 and over 1. So here we go, down 1. Oh, I just realized I got rid of the arrow on this one. Ooh, there you go. We're going to go down 2, 1, 2, and over 1. Down 2 over 1, and we'll do the same thing in the other direction. Down 2 over 1, down 2 over 1. And there you go. That is our equation. Let me just go ahead and put our arrows. There's our graphed function. And again, this one opens down. So again, the method that you're going to use for the shortcut is finding the vertex, and then you're going to go ahead and use the A value to count up and over, or if it's a negative A value, you're going to count down and over, down and over. All right. So my 2 tips just to leave you with, things to remember, is no matter if you are using the shortcut or making a table, you need to start by finding the vertex. Okay. At the beginning here, this one, when we didn't know how to find the vertex, they gave you the X values already. Okay. Notice this one, you had to, find this 5, 0 first. So in this case, you could have started by saying, oh, the vertex is, well, the -5 switches because it's on the inside, and 0 because there's nothing on the outside. There's my vertex. Let me go ahead now and plug in 2 points to the left and 2 points to the right. All right, but you also could use the shortcut here, right, and saying that the A value here is 1 over 1. So therefore, we're going up 1 over 1, up 1 over 1, and same thing in the other direction. So that's my tip number 1. Always, always, always start by finding the vertex. And tip number 2. A is not your true slope. All right, too often I see students who do this, right? They find their vertex, which here is -1, -2. There it is. And then they use 3/4 and they go up 1, 2, 3 over 1, 2, 3, 4. They put a point there. And then they go from this slope and they use this in the other direction, almost like they're doing -3, -4, like a real slope could do. So they go down 1, 2, 3 over 1, 2, 3, 4. And then they just graph me a straight line. Don't do it. All right, remember absolute value looks like a V. And that is all we have for you. All right, so you're going to continue working on the problems that are posted on Google Classroom and getting good practice with this. 30C and page 31 have some good ones on there that have some varying A values. And of course, you check your answer keys as you go.